Hey everyone, welcome back to another video. Today we are going to deploy an open source LLM that is Qwen 2.5 on a local Kubernetes cluster using Minikube, and we are going to add also Grafana monitoring with Prometheus and wire up a chart UI. And one thing I am going to do it more precisely, that is benchmark it against the different open source and commercial models like Gemini, Claude, and OpenAI. So this is going to very detailed video. So we are going to do this step by step, so please be till the end. So yeah, let's go. All right. So I'm using Minikube for local development. For production use, you can use any of the EKS or whatever managed Kubernetes you are already running. So if you don't want to use Minikube, you can also use Kind for local development, which is also suited. So I will start with the Minikube start commands. So I'm just starting the Minikube cluster. So the reason behind 4 CPU and 6 GB RAM is because we need that kind of requirement, that is minimum. So model itself needs 2 GB, and again the monitoring stacks at another 500 MB, and you want headroom for every spikes and every matrix. So basically I also tested with the 2 GB totals, and the pod gods OM kill every few hours. So that's why I choose to go with CPUs that is 4 and memory of 6 gigabytes. So I will just verify if we have Minikube is running. We will just wait for a couple of minutes. Till then I will pause the video. Cut or pen. So now I think everything is running. I will just check cluster info. Yeah, everything is running properly. Just check the Kubernetes code, get nodes. Yeah, the control plane is ready. Awesome. So the next thing is we have to create the namespace. So I will just check the YAML file. So you can see here we have the namespace name LLM stacks, and I am going to just deploy it. So you can deploy it using kubectl apply -yum command -f command, get as manifest, and sorry, 01, that's namespace. Oh sorry, I'm in a wrong directory actually. I need to be in a downloads directory. Now I will apply the kubectl apply command. So you can just check kubectl get namespace to clarify. So yeah, we have LLM stack is active. So the next thing is we have to deploy the Ollama. So the Ollama deployment has three files basically. The first one is PVC for the model, second one is Ollama server itself, and third one is Kubernetes job that pulls the model after the server start. Don't worry, I will show you everything via the YAML files. So yeah, let's get to the YAML file. So yeah, here is we have everything. We have the persistent volume claim for model storage. You can see here the we have requested the storage of 10 gigabytes. I will tell you why. And in Ollama deployment we have there is resource request, that is, and also we have also set the limits, and again we have also set the readiness probe and liveness probes. I will tell you why. And then we have this Ollama service here, and then we have job to pull the model after when the Ollama LLM starts. So I will now tell you why. So see, so the PVC, that is 10 gigabytes, which store the downloaded model, right? Without this, every pod restarts means we have to re-download the 300 MB plus libraries from Ollama registry. Basically I learned this after third or fourth time when I waited 25 minutes for a pod to come back, and I don't know why it wasn't come back. So and the next is we have also add the resource limit, like the model need at least 22 GB to load, right? So I set limit at 4 GB because sometimes there might be spikes during the batch request. So it is a safer process. And then we have readiness and liveness pros that hit slash tags, and the readiness prop stop traffic from routing to the pod until Ollama is actually serviced. So and the liveness prop restart the pod if the API stop responding. So it is the best practices actually. So now let's deploy the Ollama service. You can just copy paste the same command. Yeah, we have here. Awesome. So I will just wait for the pod to get up running, and I will set up a watch here. Quick get pods slash dash watch. So it will take a couple of minutes more. Till then I am processing the video. Awesome. So now we have both of the pods are running. So we have Ollama running, and we have also pulled the Qwen model. So the next step is here. So let's go to the next step. I will just control it, and we will just get to the next step. So the next step is we have to pull the model. So like as we know, model don't ship with the Ollama image. You pull them at the runtime through the Ollama's API. So the pull run as a Kubernetes job with an init container that waits for Ollama to be ready. As if you have seen the YAML file, you have seen there is a init container. If not, I will show you. You might have seen here there is a init container. So it wait for the Ollama to get ready, and then it pull the image. And if the Ollama is ready, then it create the init container for it. Okay, so what we are going to do, we are going to check the progress of it, if it is already is it clearly pulling the logs or not. So yeah, so as you can see, the model pull is complete and the model is verified. Now we are going to put forward the service and test the model if it is already giving the response or not. So you can just kubectl put forward. So yeah, so we are put forwarding. We will create a new terminal and just you can just curl this command, like you will just call the API and you can ask the question like which model are you. It will give you the response in a couple of seconds. As we all know, Qwen is a very small model, so it will take a couple of time. So here's the response, like I'm Qwen, and AI is a language model developed by Alibaba Cloud. So so that means the Kubernetes job has been completed. So now, the next thing is we have to deploy the monitoring stacks. So like you can't debug production LM issues without metrics. So we need to see the response latency, memory usage over time, the pod restores count, request volume, the monitoring stack include, etc., etc. And here, so it includes the Prometheus node exporter, kubestate matrix, and Grafana. So Prometheus basically scrape metrics from Ollama, node exporter, and other things every 15 seconds. So data retention is 15 days. I originally set it to 7 days and lost critical data when debugging a week old incidents. And the Grafana visualize everything with the pre-configured dashboard in the YAML file. So let me show you the YAML file here, monitoring YAML file. So you can see here it has a Prometheus config maps, everything set up. Like we have scrape Prometheus itself, we have Ollama matrix, we have state matrix, everything we have already set up in the YAML file. So what we do, we will open the new terminal and deploy the via manifest. So yeah, so we have everything is running. I will just wait, we will just wait for pod to get up in running states. So we will wait for a couple of awesome. So I think the pods are up. I will just re-verify it using the kubectl get pods command. Yeah, so everything is running properly. So we will open the Grafana, we will export it to service using the Minikube IP, and then we will set up a dashboard. Sorry, the dashboard is already set up. We will just see what it is actually there. So you can skip the new password options for now. See, so we have the dashboard already configured here. You can see the CPU usage by pod, memory usage by pod status, and then network node CPU usage, node memory usage, everything we have already pre-configured. So I will just open a new terminal because we have a couple of stuffs again. Awesome. So now the next thing is we have to build a benchmark image. So this is optional, but I recommend you to follow the as per the guide, because the benchmark API is a fast API service that runs the same 10 prompt against the different commercial models and open source models, and it will return the latency and cost metrics. For Minikube build inside the Minikube's Docker daemon, so the image is available without pushing to the registry. You can build the image using docker build command. I will just evaluate it. So it will take a couple of seconds before that, and after that you can verify if docker image is already is built or not. And then, so basically the benchmark API, it has three endpoints. First one is get health, then prompt, and then run. So health and prompt are basically health returns okay, so it check the readiness proof, and the prompts are basically return the 10 benchmark prompts and model names. And the run, so the run execute the full benchmark and return result as a JSON. So I think the image is currently building. So I will tell you how it works. you can see the chatbot here. You can have the look at benchmark OpenAI benchmark YAML file. So we have the API key setup in the .ini file, and then we have the application setup, like we have see the see here the init container. It will this will pull up all the API keys, all the model, and compare the benchmark using the UI, using the app.py file. So yeah, so Docker file is ready. I will just confirm, yeah, it is ready. So now what we will do, we have to set up the API keys. So you can have a look at the .ini.example file. We have Anthropic API key setup, we have OpenAPI key setup, and for the benchmark token, you can see you can generate a benchmark token using this command. I will just copy it and paste in my VS Code, and yeah, that's done. Now the next thing is we have to deploy the benchmark API before the chatbot UI, because that's for the chatbot UI we need the benchmark API is already deployed on the pod. So I will just deploy the benchmark API. I think everything is ready. I will just check. Yeah, all the pods are running, and then now the thing is you have to deploy the secret and roll out the deployment, because without secret the benchmark will return as the skip the job, and it doesn't return anything. So you can deploy the secret as from the .ini file and roll out the deployments. So yeah, everything is configured. So now the main thing. So I will go back to the chatbot UI. Here we have deployed the chatbot UI using the config map. So it contains actual HTML and JSON app. So you can see in the data section we have the index.html file here, and it also has the benchmark HTML file. So the benchmark HTML file will return the benchmark in the UI, as we will configure it later. So I will just apply kubectl apply command for using the chatbot API. So awesome. So and now let's check for the if it is running properly or not. If everything, I think the chatbot UI is in the containing creating state. I will just wait for a couple of seconds. So yeah, it is running. So now we will expose the Minikube service chatbot UI. Awesome. So as you can see, the Qwen chat is connected. So you can ask any question. Explain me the Kubernetes in 3 seconds. As we know, Qwen 2.5 is a very small LLM, so it will take couple of seconds to return the output. Now the thing is, the main thing of this deployment process is the benchmark. You can run the benchmark using the UI, or you can also use the curl snippet to run the benchmark. I will just copy the benchmark token here, and it will take couple of 25 to 30 seconds because of the model. Awesome. So as you can see, we have got the summary. You can see the model's name is here. You can see the Qwen's average, Claude average. So here in my currently setup, I don't have enough credit for Claude and Gemini, so I have the credit for API. So we are going to compare Qwen and OpenAI. So you can see we have categorized the models based on the category as self-identification, knowledge cutoff, technical summary, code generation, and all. You can see all the things here. So the response time, the cost. As for the self-identification, Qwen the Qwen's average is 2.94 and the OpenAI average is 2.53, and it also got this kind of this much of cost and this kind of tokens. So you can also compare the benchmark between the different kind of models. So that's pretty much from my side, and just stop the kubectl command. I will let me do it. I will just delete the kubectl namespace, delete namespace LLM stack, and you can then Minikube stop. So this remove all the resources from your local setup. The Minikube VM persists because unless you run Minikube delete, so it will take all of your steps. So make sure to delete all the resources. And yeah, that's it. That's from my side. So you have successfully deployed an open source LLM on a local Kubernetes cluster and connected it to a simple chatbot interface for testing and experimentation. So if you enjoy this video, don't forget to share, subscribe, and like. So see you in another one. Till then, bye bye.